title of the work is estimating deep ocean currents with satellite data, and the group is very small. It's me, Iury, Mengyang, Zhou, and Tobias Ferreira. And so first, why we would like to do something like this. So it's very expensive to measure currents in deep levels, and not just expensive, but it's very easy to lose the equipment as well. So that's one of the reasons that we choose working with this project. It's very challenging as well, so we could not finish everything that we would look like, but I think that we had some interesting results anyway, and the learning process is also very awesome. So starting with the area that we choose, we were particularly seeking for a place that we could find a deep current that has that may have some surface signature, and that jumps into the classic approach of the ocean currents, that we have some vertical modes. And so we kind of expect to have a signature if we have a current inversions. So we may not be exactly at the region of the deep western boundary current, but we found this data set which is the line W mooring array at the Gulf Stream. And so what we did here, the mooring point is exactly at the middle of this box, and we extracted this box. We extracted surface satellite data, ADT and SST data, to try to explore and hopefully build a model to get the deep currents. So it was very hard actually to find this data, but we can go ahead with the notebook that we built together. So
yeah, so we got the satellite data, sea surface height and sea surface temperature, and we try to correlate with deep current at 2,000 meters. This is component U, is west-east velocity. So now we took, for sea surface height and sea surface temperature, we took an aerial mean of that box, 1 by 1 degree box, and we plotted this time series with velocity. You can see some seasonal cycle here, and then we tried to do some very simple linear regression just to see how they correlate, right? This as a baseline model. So we saw a fair correlation of sea surface height with U, but not so much for sea surface temperature. Then we try to use deep learning, machine learning, to see if we can do a better job. And then I will hand it over to Tobias.
Yeah.
Please stop share screen, please, just for me to.
You are at 3.5 minutes, so you have some time.
So hello everyone. So I get the data, the two box data that from SST and SSH, and I apply two approaches, the machine learning and the deep learning approach. So first of all, we can see that the data has different variations, so SST and SSH. So first I have to scale this data, so I apply a standard scale method. And for the machine learning approach, I choose the rigid model. I tried to different machine learning models, and I saw that rigid we got the best results. And with the rigid, we apply a validation split in our data. So we separate our data in two parts. So we train the model with the first middle, and we predict the model with the second middle. And you can see that with that, applying a cross validation, we got a mean of mean absolute error of 6.8. It's not so bad, it's not so good, but I think it's a good result for a quick model, yeah. And if you calculate the mean just for the part that will not train the model, so this part here that will not use the train, we got a higher mean of 7.76. So to try a different approach, I use deep learning, and I apply the same standard scale model. I use this model here with this metric, some regularizing to avoid overfitting. I use a linear rate in decaying with the time. So I split the data with the same split, same size. And the model, I tried to fit the model. We can saw that the model never overfits, but the model did not get better with the time. It shows me that we still have to do more overtuning, fine-tuning the model with more time. But we can see that the evaluation is better. So the MA for the whole data is 5.29. So the other one is 7. So if you choose just the data that we will not choose to train the model, it's 5.59. So you can see that the deep learning got our best results, but visually looking to the data, we can see that the model is still not perfect. We still get to do more fine tuning. So next step,
still a work in progress.
Yes. So next step is to try to we apply R and dense layer. So we'll try to apply RSTM. I started to do some time series analysis, but we did not have time. And maybe try to get bigger areas, bigger box of SST and SSH to train the model with more parameters. Then we have this number of parameters here. So try to have a model with more parameters to try to fit it more with the data. Thank you everyone for your time.
All right, thank you. Please pose your questions to the project channel. Let's roll to